So I'm going to give you a little bit of a talk about using the HBP Portal. So basically you've used SpiNNaker boards that are plugged in front of you. This is a way of using the large machines, as Simon mentioned earlier on. So the way that we interact with the large SpiNNaker machines is via this portal, which is called the Human Brain Project Collaboratory, which I can't say very well. This is the web address for it. Don't worry too much about it. It's quite easy to find. You may have had to log on to here before when you were registering for the conference. Okay. So when you get into the HBP Collaboratory, you'll see various bits of information. It's quite full. There's lots of different parts of the Human Brain Project. There's lots of different platforms listed on the left of the Collaboratory page. The one that we're involved in is Neuromorphics. That's where SpiNNaker fits in. So if you select that, you can then go on and say you want to get started. So you're going to create your own Collaboratory, basically. The idea of this is that you create a space in which you can run your experiments. You can try out different things. It holds all your jobs that you're submitting to the portal. So you specify here various bits of information. You need a Collaboratory name, a description of that Collaboratory, which will give you other people an idea of what you were doing in there. You can choose to make these things public or private. When they say public, they mean people who are already on the Collaboratory can get to it, not just the general public. People have to be able to sign into the portal to be able to access these things. You can make it private, which just means you choose who gets to access the Collaboratory. And then you click create, and off you go. So what ends up happening is it will create this Neuromorphic Collaboratory. This is a specific one for doing neuromorphic things in it. So it's got some apps, I guess you call them, in this that let you do certain things that are related to submitting jobs. The first of these you would have to go to would be the resource manager. This is so that you can request some time on the neuromorphic machines, which includes SpiNNaker, but it also includes the BrainScale's Heidelberg system, which is physical neurons, and I think it also includes the spiky system that Heidelberg do as well. So you click on this settings button. Strangely enough, it looks a little bit weird, but basically when you're in the resource manager, you click on the settings and it comes up with a thing like this. So this is where you're allowed to enter the details of what you're trying to do, so that somebody can decide to give you access or not, essentially, to give you resources or not. There are different levels of access to the system. There's test access, preparatory access, and project access. Basically, test access is, I just want to try out the system. So you get something like 5,000 core hours on SpiNNaker, I think, for test access. Preparatory access is, I've got this thing I want to try out for, a bit of a bigger project. So I want a bit more time to be able, on the system, I want to run slightly larger networks. Then project access is, I'm going to be running some big networks. I'm going to need a lot of time on the system. For the project and preparatory access, you actually need to give a project description as well. So someone's supposed to evaluate these things to decide if your project is good enough to give access to the system, essentially. I suspect we're not going to deny you at this point, but these are for in case we end up with an overloaded system in the future. And then you submit your proposal, basically. And that gets you into the system. This will actually go off now to someone in the Neuromorphics team who will have to decide whether to grant you access, decide how much core hours you get for each thing. So once that's been done, you will actually get an email back saying your access has been granted, or rejected, I suppose. Assuming it's been granted, you'll get something. When you go back to the resource manager, it will look something like this. So it now shows you, in this case, we've got 0 of 5,000 core hours on SpiNNaker. Basically, you can see this 5,000. This one was test access that I did just for a demo, just to see what happened. So once you've got your access, you're now able to access the system. You have to go to the job manager to be able to submit jobs. Once you're there, this is actually a listing of all the jobs that have been submitted. This was a new collab, so there weren't any jobs in it. So you want to say new job. I'm going to submit a job. You can choose between the various hardware platforms. Obviously, if you're doing SpiNNaker, you choose SpiNNaker. It's quite simple. You get to enter your Pine code here. So you can enter a Pine script, much like you've been entering in any of the examples you've been trying. You've been writing a Python file which contains Pine script. You can do exactly the same here. There's actually an editor, so you just write in a big Pine script, and then you submit your job, and off it goes to our platform. This is run in batch mode, So what happens is, first of all, when the job's been submitted, you get a submitted status. You get told you'll receive further updates by email. So you'll get emails saying what state things are going through. The job goes eventually into a running status once our system grabs the job and starts pushing it onto the system. And then you get a finished status, so the job is done. We can now view the results of the job. And in this case, there isn't much interesting to see in this job. So I did a very quick job. I don't know if you can see the text at the bottom here. Basically just import p.setup, print test p.end. So it doesn't do anything interesting. So there's no actual outputs here. However, there is an output file. It's the reports. I don't know if you've noticed this when you've been running your jobs, but basically when your job's complete, there's actually a reports folder stored on the system. And that reports folder contains a number of bits of information about how the job ran. It tells you things like, were there any lost packets on the SpiNNaker network? Did anything overrun its time? You do see these warnings at the end sometimes. You may have seen them in running the Sudoku example, for example. These are actually logged in files as well, so you can look at them later. So our system zips up that report folder on the remote system and hands it back to you at the end, so you can go and see what happened. It also would give you some provenance. Currently, the only provenance item is this Collaboratory, because my job was so simple, there wasn't actually anything that happened. It also gives you the output log at the bottom. Of interest, while the job is running, if you keep clicking the little down arrow on this output thing here, it will actually keep updating that log, so you can see things as they progress as it's running. It's a live update system, so you can actually watch it if you really want to. And as I say, although it's a batch job, the system isn't heavily used just now, so you'd probably be able to actually see your job progressing through the system quite quickly if you do try it. However, if everybody in this room tries and accesses it, you probably won't. It'll start going into more of a batch mode, and it wouldn't be so exciting then. Yeah, and as I say, see later, I'll cover a bit more of the provenance that happens when you get a more interesting job. So okay, we've done a very, very simple job. We submitted a script. The system, actually supports other things other than just writing a script in the editor. You can select here to Git repository or zip archive, and you can enter the URL of that. So if you have it has to be an open Git repository. If you enter the URL of that Git repository as something.git, then it will take a copy of that Git repository and execute your files from within there. And similarly with a zip file, it has to be a URL at this point. I'll cover what happens if you don't have a URL for your zip file in a minute. You do have to specify the command that it's going to execute, though. So it's not automatically just going to run something, because you don't know what the file is going to be called in your repository. So if you've got a file called run.py, it'll actually pick that by default, but you might have called it script.py or start.py or anything like that. So you need to specify the name of the file. If the file's in a subfolder, you need to specify that as well. So it's the path to the file to run, and it'll execute your file. It has to be a Python file at that point, so it's going to always put Python before whatever goes in command there. You can specify other Python options, which I'll cover in a minute. So yes, if you don't have access to, you don't have a URL for your zip file, so you haven't got a web server somewhere that you can upload it to, the Collaboratory also includes some storage within it. You can then, for example, upload a file into here. Select your file, you drag and drop, standard nowadays how to get files into browsers. And then when you're finished, you upload those files. Now, when you come back to the job manager, there's actually an option to do from Collab Storage. So you can now select the file I've uploaded. In this case, I uploaded a file called SynFire Collab. So it's a bit like the SynFire you had, but there's a slight difference, which I'll cover in a minute. You select that file to run, and off it goes. So this file produces a output like this. So it looks very similar if you've managed to run the Sudoku example. However, this is a PNG file, so the name of the file at the bottom is something.png, results.png. Now, by default, if you used matplotlib's show, it wouldn't produce this file. So you have to be aware when you're running on the Collaboratory, you do need to modify your script slightly. So instead of saying pylab or plot.show, you say .savefig, and then specify the name of the file that it's going to write. Any files that you output from your script in the Collaboratory it will bring them up on the output files. So, and if it's a PNG file, it will display it physically rather than actually just giving you a link to it. You can download those files as well, so just clicking on them. So if you produce a data file of some sort, you can click on it and download it for later. But yeah, just be aware if using matplotlib, it works, but just make sure you do a save rather than a plot than a show. To come back to the provenance, you can see here some more provenance has been written into the system. Now the output of this is a little bit rubbish at this point. It is being worked on. We don't control the portal, it's team members at HBP that are also working on this, and they're going to make a better viewer for the provenance, I believe. But you can see here some of the items that we put in. So we actually tell you which SpiNNaker machine you actually ran your job on. Now this is an IP address, but it means something to us. So if something goes wrong with your job, we can then follow up what happened, possibly if there was a machine fault. There's also then router provenance, so it tells you if did we lose any packets. We created 4,832 packets in this example, and we dropped none of them, not surprisingly, because it's quite a simple example. And it also gives you the software versions that have been executed here. So if you were trying to match up with something later on, you could make sure that you know which versions of the software there is. That's the current things we store in the provenance. As I mentioned earlier, that reports file contains a lot more data as well. These are sort of the things we thought were mostly important to report back to the collaboratory itself. And of course, there's a log down there again, so you can see any real low-level details of the running. Other things you can do with the Collab storage, excuse me, you could create a folder in there and put some files in it. Much the same, so you could put a list of files in, for example, rather than just a single file. You can then execute this, so in a similar way, you now select your folder instead of selecting the file to run, and you type in the name of the script that you're going to run with the folder in front of it. So that can also work. Another thing you can actually do this is make this into a module, so you can create a whole module hierarchy under here by putting in underscore init .py files into the system. And now when you want to execute this, you can actually use -m folder.module without the .py. Now this is just a Python specific thing. If you did this on Python command line, it would work the same way. The advantage of this is it makes your folder into a module, which means you can have other things in that module, for example, and you can have submodules which you can then reference from that script. So you can now start to build a whole Python program with lots of different moving parts if you want to. Oops. There it goes. Did I have something different in that one? Nope. Okay. So the other thing you can do is you can actually upload a zip file into the Collab storage, so to give you more examples, and this might actually work, for example, with new models, which will be covered later on. So if you have your own pre-compiled binary files, you can include them in as a big zip archive. You can include lots of examples with lots of underscore inits, so there's each of these folders has inits in it so that it can all link together. You'll see an example of this on Thursday when we're covering the new models. So yeah, you can see how this actually works, but this is something that you can do with the Collab. And then you can select your zip file here. So instead of selecting a .py file, you select a zip. It knows in the system that means it needs to be expanded and run. Again, use this -m sort of way of specifying the command. And if I go back to this slide, I've specified this came in the examples folder. My example is the script I'm going to run. And so I do -m examples.myexample without any .py. And that'll let it execute from the Collab storage. So if you come back into the collaboratory after a while, you may forget where everything was. You've just done all this and now you've lost your Collab. So you want to go find that. There's actually a link at the top here that says Collabs. You can go back in. You can then see, you can actually initially get to see every Collab that is exposed to you. So every Collab that is public is listed in this big page. You can filter them, search for things. Probably the most useful thing is then look for my Collab. So you want to find your own Collab. I have made a SpiNNaker Workshop 2017 Collab. You should all be invited to it, but if you can't get into it, let me know if you don't see that on my Collabs. That has already had the resource manager bit done, so I've applied for some time on SpiNNaker and accepted my request, because I can. But obviously I can do that for other people as well if they need to. But yeah, this has been approved and you've all been invited to this Collab. Now there is a bit of a requirement with the HBP portal, which is we're supposed to get people to do passport scans and email them into us. So I've bypassed that requirement for now, but after this workshop I may have to uninvite you from this collab temporarily, and if you want to access it you have to email us passport scans and things. It's mainly for the Heidelberg systems, because getting access to this gives you access to Heidelberg system. They have export licenses with their system because it includes plasticity processing. Our system does plasticity processing, but it isn't a plasticity processor, and therefore we get around the export license problem. But yeah, because you'll be essentially able to also access the Heidelberg, the brain scale system, we have to take these passport scans, and you have to sign a form somewhere or something. But if people need details of that, let me know, and I can sort it out for you. Oh yeah, so some of the things I was going to say in the future. Currently, when you run this, you get Pine 8, the current version of the tools you've just installed. That's what you get to run. There's no choices. I'm in the process of making some changes that should let you choose which Pine version you want. So if you were using Pine 7 and you want to continue doing that, you could possibly do it via here by saying I want Pine 7. Also, if you were working at the low level on the tools and you had some different version of Git, or we'd done some fix for you and said, okay, we fixed this problem for you, it's in this branch, we've not merged it yet, you'd be able to specify which Git branch or which SpiNNaker version you want to run. And again, if you use this provenance data that's telling you the version of the software, you'd then be able to say, I need this version of the software because it used to run on that, and it doesn't run on this, or something like that. You know, you've got some reason for running it on a different version, you'll be able to. So that's a possible, well, it is a future change that will be coming at some point. And I think that is it. Any questions?